Welcome back to a new video lecture, and in this lecture we will discuss about the derivation of slope deflection equation. So with the help of a continuous beam and some loads are acting over it, I will explain the derivation part. Okay. So here a continuous beam is given and we are only considering a small or intermediate part from this continuous beam. Let this beam be AB and a UDL is acting over it. Okay, this is the condition given. Okay, and here when this UDL is acting, there will be a chance of some deflection is going to happen. And here you can note down that after deflection, there is some rotation is going to happen at the joint A, and that is given as theta A. And at the joint B, you can note down that there will be a theta B. Slope is given, and some vertical deflections you can note down as delta. And we know that we are only taking a small intermediate portion from this continuous beam, and some internal moments will be developing at the joint A and at the joint B, and that you can represent it as MAB and MBA. Okay, at the joint A, the internal moment will be MAB, and at the joint B, the internal moment will be MBA. Okay, so our final intention is to calculate what is the magnitude of this MAB and what is the magnitude of MBA, and that equation is here. Okay, for that we will go through some certain steps, very easy steps. Okay, and before going to that, we need to identify some of the sign conventions which we are following. Okay, if the n moment's direction is clockwise, then we will consider it as a positive. If the n moment direction is positive, then we will consider it as a positive. And if the slope direction, that is theta A and theta B direction is in a clockwise direction, then it is also positive. Then there is a condition called settlement. Settlement, how we will identify? If this is a support and it is going to be settled in this way, means if this is A and this is point B. Okay, let us assume this point A, and so when you are comparing these points B with respect to A, that is the A portion is in the upper portion, when compared with B, then it is also going to be taken as positive. And one more condition, that if it is in a case of frames, if this point, this is A and these points are B, and if it is deflected in this direction, then also it will be taken as positive. Okay, once again I will repeat. Here this is a framed structure. Let us assume this is a frame, and if you are applying some loads in this format and some deflection is going to happen in this direction, then also you will take the value as positive. Okay, so these are the sign conventions which we are following in this slope deflection method. Then we will move on to the different steps which we are following to come up with these equations, final equation. So first of all, we need to make sure that this both ends to be fixed. That is our first condition. You have to make this both A and B to be in a fixed condition, and some loads are also acting here, and you have to calculate the end moments. That is, you can note down that this value is MFAB and here MFBA, and here the directions you can put down as always one of the end moments will be in clockwise and the other will be in anti-clockwise. So here it is in anti-clockwise direction. Let us assume in anti-clockwise direction, and here it is in the clockwise directions. Okay, and we will also discuss about the end moments. What's the values? That means when a UDL is acting over a fixed end beam, here some UDL is acting here, then what will be the value? MFBA. Okay, and MFAB. Likewise, some general values also there. Okay, that you have to by heart. That we will discuss in the next section. Okay, so here we are only focusing on the derivation part, and after that, after this step, you have to go to the next one. That means here you are going to release this this fixed end. You are going to make that this end A to be free. Okay, that means you are keeping this end B in a fixed mode and the support A to be in a free mode. Then some rotation is going to happen, that is theta A is going to happen at the joint A, means this end is going to be free. Okay, so here if you are applying a moment of magnitude for EI by L theta A, if you are going to apply a magnitude of 4 EI by L theta A in the clockwise direction, there is a condition called, if you are applying at the free end, the value at the fixed end will be 50% of this value. Once again I will repeat, here the value is going to be, the moment we are applying is 4 EI by L theta A. Okay, and this is applying to this free end, and this value is going to be transferred. This value is going to be transferred to the fixed end with 50%. That means it is going to be half, that is 2 EI by L theta A, and the direction also will be in the clockwise direction. Okay, and in the second step we are going to make this end A to be fixed and this end B to be in the released mode. So here the slope is going to be theta B, and if you are applying this value at the free end 4 EI by L theta B, the magnitude going to be, means it is again going to be 50% to be transferred to this fixed end, and the value is going to be 2 EI theta B by L. Okay, this is the condition for this derivation part. Okay, so you can either use this method or there is another method called moment area method, moment area theorem. You can use that also to derive this equation. Okay, and the last stage, you have to keep this both the ends to be fixed and some deflection is going to happen. Once again repeat, both ends to be fixed, and after fixing there is some deflection, vertical deflection is going to happen. And if you are giving this both ends to be fixed, okay, and if you are giving a magnitude of moment 6 EI by L square delta, the same value will be transferred to this side also, since both the sides are in a fixed stage. Okay, so this is actually a condition. When you are keeping this fixed end and in the free end, how the moment is transferred, and when a fixed end and both ends are fixed, how the moment is transferred. In the case of both the ends are fixed, the same magnitude will be transferred. But in the case of free end and fixed end, if you are applying some moments in the free end, 50% only will be transferred. This is actually a condition. Okay, we have to note down what all values you have got in the this support A and the support B. Just note down the final moment, that is called MAB, and which is equal to this fixed end moments MFAB. Okay, this fixed end moment sign here, it is in the anti-clockwise direction. So while calculating, this is actually a representation. While calculating the values, you can note down whether it is positive or negative. Likewise, you can put down in that manner. Okay. Then here the value is in the clockwise direction, that is 4 EI by L theta A. Then you can write down in here. Then the second value at the support A is it is also in the clockwise direction, plus 2 EI by L theta B minus 6 EI, it is in the anti-clockwise direction, 6 EI by L square delta. And here when you are framing that, you can take down this 2 EI by L common outside, and you can write down the equation in this format. And similarly in the right side, that is at the joint B, the MBA, which is going to be MFBA, that is in the clockwise direction, that is according to your values, whether it is positive or negative, you can put down that value. Okay, this is actually a representation. Okay, don't get confused. Okay, so here the value is going to be the next value, that is here it is 2 EI by L theta A plus 4 EI by L theta B, and here it is in the anti-clockwise direction, that is why it is given as minus 6 EI by L square delta. And these two values, this MAB and MPA, with the help of this equation we will work out the problems. Okay, And regarding this fixed and moment, that we will discuss in the next section. Okay, so for various conditions, if the two ends are fixed, then where UDL is acting, what about the MF fixed and moment? When a point load is acting, what about when a UVL is acting? And then likewise, so many conditions are there that we will discuss in the next section. Okay, this is regarding a very simple method of working out this derivation. There are another method and which is regarding with the moment area method, that also you can use for this derivation part. Okay, so I hope the section is very clear, and with this we will wind up today's section. Thank you.